All right. Hey, today what we're going to do is I'm going to have this BOV on 7.3. This deals with the atmosphere, talking about pressure and density of the atmosphere. Let's go ahead and scroll down. Have your ears ever popped? If your ears have ever popped, you have experienced a change in air pressure. Ears pop because the air is different on the inside and the outside of your ears, whether you're climbing a mountain or in a plane, whichever. The properties of air. We usually can't sense the air around us unless it's moving, but air has the same basic properties as other matter. For example, air has mass, volume, and of course, density. Density of air. Density is density is mass per unit volume. Density is a measure of how closely molecules are packed together. That's why I refer to it as how tightly packed the stuff is in something. The closer together they are, the greater the density. Since air is a gas, the molecules can pack tightly or spread out. The density of air varies from place to place. Air density depends on several factors. One is temperature. Like other materials, warm air is less dense than cool air. That's why hot air rises. Since warmer molecules have more energy, they are more active. The molecules bounce off each other and spread apart. Another factor that affects the density of air is altitude. Altitude is the height above sea level. The density of air decreases with height. There are two reasons. At higher altitudes, there is less air pushing down from above, and gravity is weaker farther from the Earth's center. So at higher altitudes, air molecules can spread out more, and air density decreases. Here, this is a typical column of air. This is just a vertical segment taken out of the atmosphere, and you can see the closer to the Earth, closer to sea level, you have a whole lot more molecules all crammed together. But the further that you go away from the Earth in the upper layers of the atmosphere, you don't have as many. Air pressure. Because air is a gas, its molecules have a lot of energy. Air molecules move a lot and bump into things. For this reason, they exert pressure. Air pressure is defined as the weight of the air pressing against a given area. That looks like a good definition. At sea level, the atmosphere presses down with a force of about 1 kilogram per square centimeter. That's 14.76 pounds per square inch. If you're standing at sea level, you have more than a ton of air pressing against you. Why doesn't the pressure crush you? Air presses in all directions at once. Other molecules of air are pushing back. Altitude and air pressure. Like density, the pressure of the air decreases with altitude. There is less air pressing down from above the higher up you go. Look at the bottle picture below. It was drained by a hiker at the top of a mountain. Then the hiker screwed the cap on the bottle and carried it down to sea level. At the lower altitude, air pressure had crushed it. Can you explain why? Because air, that's usually at lower places in comparison with mountains, has a greater concentration of gases than those that are high up in altitude. So therefore it crushes it. Well, we have some vocabulary words. Air pressure, the force of air pressing down on a given area. Altitude, the distance above sea level. And density, mass per unit volume. Density is equal to mass divided by volume. It also measures how closely molecules are packed together. And there you have it. Let's watch this little video on air pressure versus altitude.
Let's talk about air pressure. What is air pressure? To learn about air pressure, we must first define what pressure is. Pressure is the effect which occurs when a force is applied to a surface. P equals F divided by A. The force of air is caused by particles in the air being pulled toward the center of the earth by gravity. Since air is made of stuff, it has mass and weight. Therefore, it creates a pressure due to gravity pulling the stuff toward the center of the earth. Picture a clear plastic tube going from a spot on Earth to 600 miles above sea level. That is where the atmosphere ends. In other words, there is no more stuff. Now let's fill the tube with eggs. The eggs at the bottom of the tube will have greater pressure on them, causing them to break and become more dense as the eggs now fill all the space in the bottom of the tube. The eggs near the top of the tube have less pressure on them because there are fewer eggs above them. With that picture in mind, you should be able to get an idea of air pressure. The farther from Earth's center you stand, as on Mount Everest, the fewer eggs above you and the less pressure. The closer to the center of the Earth, as in the Sea of Galilee, the more eggs above you and the greater the pressure. We can measure the air pressure using different instruments. We have manometers and barometers. The barometers can be mercury barometers or aneroid barometers. An altimeter is basically an aneroid barometer. One of the most interesting places in the United States at sea level is Key West, Florida. The elevation of Key West is sea level to a whopping 18 feet on top of Solaris Hill. Air pressure on a standard day in Key West is measured at 29.92 inches of mercury, or 760 millimeters of mercury, or 1013.25 millibars. On top of Mount Everest in the Himalayan mountains, the altitude is 29,028 feet. That is about 5.5 miles high. The air pressure is so low that people who climb Everest usually need to have extra oxygen with them. Woo, I could use that myself. Once again, you have a lower pressure than at sea level because there are fewer air particles above. The highest point in the state of Georgia is a mountain peak called Brasstown Bald. The elevation is 4,784 feet. Remember, you have a lower pressure than sea level because there are fewer air particles above. Reducing our altitude below sea level, we travel to the Salton Sea in California. The altitude is 220 feet below sea level. And since we are below sea level, we have more particles of air stacked above us, hence greater pressure. More stuff means more weight and a greater force. Finally, we are at Lake Kinneret, the Sea of Galilee in Israel. Lake Kinneret is the lowest freshwater lake on Earth and located in the Great Rift Valley. The elevation of the lake is 696 feet below sea level. Because there is more stuff above us, like at the Salton Sea, the pressure is greater. Now that you know the elevations of these locations, use the air pressure versus altitude chart to determine the approximate air pressure on a standard day for each location.